Hello everyone, in this video we're going to dive deep into one of the most important tool in calculus, the power rule for derivatives. And this rule is so simple that anyone can use it to find slopes or velocity. And we can find the use of this in every single field. For example, in math, physics, economics. And there are many benefits of using power rule because it works for every single real numbers, whether it be negative exponents, positive, integers, all natural numbers, and it's everywhere in math and physics, and it applies to polynomials. Polynomials means x raised to n, and n can be any numbers, and power rule is used to find slopes and velocity. And now we're going to use power rule to solve real world examples. But first, we need to understand, we need to know what does it look like. All right. Suppose we have a function f(x), which is x raised to n, and n can be any constants, but not like trigonometric functions. It cannot be like that. It cannot have any variables like x and y. It should be constants. For example, 1, 2, 3, 4, 5, or any real numbers. A constant means that the thing that doesn't change its value, right? So, and to find the derivative of f of x, we take this exponent in the front, multiply with x, and we subtract 1 from n. For example, suppose we have a function x raised to 5. So to find the derivative of f of x, we take 5 in the front, multiplied by x, and we subtract 1 from 5, which is 4. And this is our answer. And for the real world problems, for example, just imagine that you are driving a car, and the position that you have, the distance you have traveled, is determined by the function like this. For example, fx and 8t squared, right? And the your position depends on the square of time, all right? And to find the derivative of this, we would multiply it by 2, which is 16, and t, and we subtract 1 from 2, which is 1. So this is the example, and this is the velocity is the derivative of position with respect to time, and this derivative is nothing but our velocity. And to find the acceleration, we differentiate this velocity. So, and which is 16, and what is the derivative of time with respect to time? It's 1. All right. So our acceleration is 16 meter per second square, and our velocity is 16 t meter per second. All right. So in 1 second we travel 16 meters. In 2 seconds we travel 32 meters. All right. And this was it. So to understand more, I'm going to upload a lot of video in the future. Thanks so much.